Today we'll be using processing. You can download it from the processing.org website. We'll be using more specifically processing.python, so if you go to py.processing.org, there's all this great reference material on and documentation on processing.py. When you have processing downloaded, you are going to go to this drop down up here and go to add mode and make sure you add Python. We're going to be using the Python mode, not the Java mode. Just so you can follow along with this tutorial. And yeah, we'll be making a Starfield. So it'll look something like this when we're all done. Okay, thanks for watching. A Starfield project. I'm going to start by creating one star, have it fly off the screen, and then we'll create multiple stars. We'll create this whole Starfield. So we're going to start with def. We're using this built-in function, setup. Inside of setup, we are going to say that we're going to be using a global variable called star, so we can use it in different functions. We're going to set the size of our window to be 600 by 600. Of course, if you have a bigger screen, you want to make it bigger or smaller, that's fine too. Then we are going to create our star. It's a variable called star equal to a p-vector. A p-vector holds two different values, an x and a y, and we're going to set this to be random 0 to width. Let me put a comma in there, 0 to width. You can see width turns this red color, pink color, I'm not sure. It's a global variable, it's the width of the screen, so our width is going to be 600 because we set it to be 600 inside of the size. So that's what that value is right there. And the other value of the p-vector is going to be like our y value, and it's going to be set random 0 to height. Again, height will be equal to 600. Let's close off that bracket for the p-vector, and that is our star variable. Next up, we're going to go into our draw function. This is a built-in function that will get drawn over and over again on top of the screen, so our stars can move. Global star, let this function know that we're going to use this global variable inside of this function. We'll set our background to be 0, which is black. We will set our fill, so the color that the shape is filled with, to be 255, which is white. And then we will define the center of our screen. The reason why we want to create this variable for the center of our screen is because we want to move the stars away from the center. So this is going to make that possible. So our center is going to be equal to a p-vector width divided by 2 and height divided by 2. Because both of our star and our center are a p-vector, it will make subtracting really easy. Next up, let's create our star, which is going to be in the shape of an ellipse, so just like a circle. And I am going to use star.x for the x value, and star.x, remember, we created that up in our p-vector, so star.x is this first value right here, a random number anywhere from 0 to width. Next we will create star.y, which is the second random value that we created inside of our p-vector star. Then we need our size. I'm going to set our size to just be 10 and 10, so 10 width, 10 height. It's a little bit bigger than a star, but then we'll be able to see it easily on the screen in the beginning. And then I'm going to do star plus equals star minus center. So this is where I was saying the subtraction will be easier because our star is a p-vector and our center is a p-vector, so we're able to subtract one from the other, and it makes the math a little bit easier. Next I'm going to multiply that by 0.05, and that's kind of like our speed, how fast the star will move away from the center. And then if I press play, I see the star. It's flying off the screen really quickly. Yeah, you can see it fly off the screen, but as soon as it flies off the screen, it's gone and it doesn't come back. Oh, there it goes. Okay, so what should we do if it flies off the screen? Maybe you want to try to figure that out on your own, and then I will, if you want to pause the video, try to figure it out on your own, you can, and then I will show you how to figure it out, how to do it. So what I'm going to do is I'm going to put in an if statement. If star dot x is greater than width, or star dot x is less than 0, I'm just going to reassign this p vector. I'm going to do the same for star y. If star y so if the star y is greater than the height or less than 0, then I'm going to reassign the star variable to be a new random width and height. So now if we press play, we should see the star fly off the screen, but then it reappears in a random spot and then flies off the screen again. So this is the start of our star field, but it doesn't really look like a star field yet because there's only one star flying off. So next up, I'm going to create a list and put a number of different stars in there and then have them all fly off. So it looks more like a star field. To start this off, I'm going to go to the top of the screen and I'm just going to create an empty list. So stars is equal to open, close, square brackets. It's just an empty list. I'm going to create a variable called number of stars. I'm going to start that off. Oops, I'm going to set that equal to 100. And then I'm going to create a variable called speed. I'm going to set that equal to 0.05, just like we had before. Now I'm going to put all these three variables as global variables, so stars, comma, number of stars, and speed. Then I can copy this and paste it down in my draw function as well. Then after I do the size of the window, I'm going to create a for loop for I in range so this will loop through for the amount of for the value and number of stars. So for us it will go up to 100. So inside of here I'm going to create a variable called location, and I'm going to set it to be equal to a p vector. So I'm just going to cut this and paste it up here. So location is equal to p vector x and y of random values somewhere between 0 in the width and 0 in the height. Next up, I'm going to create another p vector variable called star size. I'm going to set that equal to 7 and 7 in the beginning. And then I am going to call that empty list that we created. We called it stars. So I'm going to say stars.append. Append just means I'm going to add something on into this blank list. And the things that I am going to add into this blank list are location and star size. Oops. And this is going to create my list of the locations of the different stars and also the size of the different stars. And just to see what it looks like, I'm going to print this out. Actually, I'm going to go a little bit further, and then I'll print it out and show you what it looks like when we're working in our draw function. The reason why is we still have this variable star that's no longer defined, so it won't actually run. So let me go a little bit further, then I'll print it out. Everything's going to stay the same up until we create this center. After this center, instead of creating one star, we're going to make another for loop, and we're going to make a number of different stars for each item in our stars list. So for star in stars, what this will do is it will loop through everything in the list stars, which we made a blank list here. Here we filled it up with the p vectors, and here we're looping through it. Each time it goes through, star is going to be equal to the first item, and then the next item, and then the next item. Okay. Inside of here, we are going to create this ellipse. So I'm going to cut this, and I'm going to put it inside of this for loop. But now I want to create star 0.x and star 0.y. Now for my size of my ellipse, I want to use the size that we created inside of our list, our p vector, our star size. That's what I want to use. So the name of that is going to be star. I'm using this variable here, star. It's going to be the first index number dot x. And I'll do the same. So I'm going to copy that. This is the width, this is the height, and I'm going to change this to dot y. Maybe sometime in the future we might want to make different values here. Right now they're the same value, so it doesn't matter too much, but I think in the future maybe we might want to change that, so that's why I'm doing it this way. Next up, I'm going to cut this line, and I'm going to put it in here. This is going to be star 0 plus equals star 0 minus the center times 0.05, and I'm just going to put that global variable speed in there. The reason why I'm using this global variable speed, it's equal to 0.05, so it's the same value, but now I can alter it. I can adjust this variable speed. I can make it go faster or slower to change the speed of the stars, so it just gives me a little bit more freedom. Now I'm going to change these if statements, so I'm going to cut them. I'm going to put them inside of the for loop. Make sure my tabs are correct. Okay. Now this is going to be star 0.x. And this is going to be star 0. And I'm also going to, oops. Also create another p vector. So this I can copy, and I can paste down here. And here I need to add in the 0, so if star 0.y or star 0.y. Alright, that looks pretty good. So now when I press play, I'm going to print out these stars, and we're going to take a look at this list that we created. Maybe for the first one, I'm going to change this from 100 to 10, just so it's a little bit easier to see. And these stars will print in the console, so we get a better idea of the list and how we're looping through it. So there's our Starfield. Looks like it's working pretty well so far. But let's take a look at this list down here in the console. So you can see from the square brackets to the square brackets, there's going to be two different p vectors in each of these. So the index number of this one is going to be that 0 and then the 1. That's why inside of this for loop, when we're creating our stars, we're using these numbers, these index numbers 0 and 1. 0 for the star location and 1 for the size. So by printing out that list, you get a better understanding of the values we're using and yeah, how we're creating the star field. But I just wanted to show you again I just want to show you really quickly. There are 3 values here. You can see there's an x and there's a y. P-vectors also allow you to use a z value as well. I'm not using the z value, so all you'll see in each of these entries, there's a 0, 0.0, 0, 0.0. That is the z value. So if you did want to use an x and a y and a z value, you could with the p-vectors. That's why that looks like that. All right. It looks like our star field is working, but I want to make it a little bit more interactive. So the first thing I'm going to do is I'm going to change the center. So I'm going to change the center from half of the width and half of the height to mouse X and mouse Y. And when we go on our star field, we can move our pointer around our mouse, and it kind of looks like we're flying through the stars. We're directing our spaceship where we want to go. To make this look a little bit better, I think I'm going to add a 0 on the number of stars. I'm going to have 100 stars, so it looks a little bit better. The next thing I am going to do is I'm going to make it so we can adjust the speed of the stars flying past. So for that, I'm going to create a new function. It's going to be called keyPressed, lowercase k, capital P. It is a built-in function that will check for which keys are pressed on the keyboard. I'm going to bring in the global variable speed. So if key code is equal to up, so the up arrow on the keyboard, then I want to increase the speed. Oops, that's spelled down correctly. All capitals, D-O-W-N. So if the key code is down and the speed is greater than 0, so I do not want to make my spaceship be able to go in reverse, so I'm just going to stop it at speed 0. So if the key code is down and the speed is greater than 0, I'm going to minus, so speed minus equals 0.01. So then when we press play, we should be able to direct our star field, we should be able to speed up, and we should be able to slow down. Cool, and then they stop. Nice. It doesn't look great to me because the stars are staying the same size as they travel by. So I was thinking that we should change the size of the stars as they're flying by, just to make it look a little bit better. So I'm going to do that inside of our draw function. Inside of our for loop, we're creating our stars. And if we reach the end of this and the stars haven't flown off the screen, then I want to increase the size. Alright, so I want to increase the size of the stars as they fly by if they haven't flown off the screen. So I'm going to say star 1, because dot x, that's going to be the width. I'm going to add the speed onto the star. So the star will increase by the speed it's traveling. So let me grab one of these stars and keep it from flying off the screen. You can see if it stays on the screen longer, it gets larger and larger and larger before it flies off. I think I'm going to adjust the size of the stars a little bit. So I'm going through and I'm setting all the p-vector sizes to 3. So they're a little bit smaller, and I'm just going to see how that looks. I like how that looks a little bit better. You can see that the stars that stay on the screen are increasing in size. We can increase the speed. We can slow down the speed, but we can't go in reverse. And we can also move the Starfield around with our mouse. So we made it a little bit more interactive. I hope this was helpful. I hope you learned a little bit about processing.py. Maybe you learned something about p-vectors and how you can use that vector math to make objects fly across the screen. And yeah, thanks for watching.